right? Because the prompts they give you are either tables, equations, or graphs. So with 6 questions, they will definitely hit all of those at least once. So you got to be comfortable with graphs, the tables, and with equations. So this section is all about tables and what we can learn and do with them. All right, number 1, the height of a tree at a time t is given by a twice differentiable. So that means we can take 2 derivatives. That means the second derivative exists. Function h, where h is measured in meters, t is measured in years. Selected values of h are given on the table. Okay, so let's pause for a second and make sure we understand what we've got before we start looking at questions. So they're telling me the height of a tree at a certain time. So again, sometimes they like to give you a rate here, but this isn't a rate, this is the actual height of the tree, which means they're probably going to ask about rate if they didn't give me rate. Question A, use the data in the table to estimate h prime of 6. Well, that's the rate. That's the rate of change. 1a, h prime of 6. All right, that's the same thing as rate of change. That's dh dt. Now it says estimate. You know why it says estimate? Why didn't it say just find? Oh, we don't have enough information to find it. Like finding it, I would need an equation. Maybe a graph if I could pick off the slope. But with this, the best I can do is estimate. And we can estimate because the average rate of change will approximate the instantaneous rate of change, right? So h prime is the instantaneous rate of change. That's the derivative. We don't have an equation, we don't have a picture, so I can't find that, but I can approximate it with an algebra slope. And let's see, if we want at 6, we should probably use 5 and 7. I don't know what they would do if you use different points, right? If you use 3 and 10 and said that's an approximation, because arguably it is, but the best approximation would be using the values closest to 6. So 11 minus 6 over 7 minus 5. Using correct units, which means may as well put the units on our calculation here. 11 minus 6 is meters. 7 minus 5 is years. So I guess that would be a safe stop, but I'm going to go ahead and... So 5 over 2 meters per year. Or 2.5, but 5 over 2 is fine. Okay, using correct units, interpret the meaning of h prime of 6. So what? Anybody want to take a stab at it? What is the meaning of h prime at 6? Ben? Oh, you got something in your mouth. You're pointing right? Okay, slope at 6. That's sort of right. That would not get you full points, though, because it says in the context of this problem. So you're right, it's the slope at 6, but what does that mean for this particular problem? Bailey?
The rate at which the tree's height is, or at 600, or 6 years.
The rate at which the tree's height, what'd you say? Grows?
Or increases.
Okay, grows, increases, changes, all of those are fine. I'm going to say changes. That way I don't have to worry about the positive or negative, right? If you do increase, decrease, then you better be careful about negative, right? Because decrease, but add a negative, does that mean stick with changes. The rate at which the tree's height changes in meters per year at 6 years. And it really should have all of that. So the words they would be looking for is rate, meters per year, at 6 years. So, Ben, do you understand why your answer was like technically correct, but not what they were looking for?
Yeah.
Yeah, it is the slope of h, but like in the context of this problem, what do you mean by slope of h? They really want you to say rate, and they want you to get the units and the time. All right, part B. Explain why. Oh, this happened on the FRQ on the practice test. Explain why there must be at least one time such that h prime equals 2. Well, if it's a must happen, then there's only there's 3 existence theorems. This is a little side note here. 3 existence theorems. Extreme value theorem. That was referenced on the test. Some of you figured that out looking at the formula chart. That just means if a graph is continuous, it has an extreme value. Intermediate value theorem, again, if it's continuous, then every value between the lowest and the highest is in there somewhere. That's the intermediate value theorem. What's the mean value theorem tell us? Just a quick phrase. What is the mean value theorem? I mean, it's on the formula chart, but even easier than that, calc slope equals algebra slope. And MVT is the only one that deals with slope. Extreme value and intermediate values are about the values of the height of the tree. MVT deals with slope. So if you get a problem that says, explain why, or is there one time when a derivative is involved, it's almost certainly going to be an MVT problem. Okay, so MVT. If you want to use MVT, you have to say why you can use it. You have to give the conditions. So a bunch of you, I forget what number it was, I graded them last night. There was an MVT problem on the free response question, and a bunch of you got MVT, but most of you didn't say why you're allowed to use MVT. So do you remember what the conditions are to use for MVT? Continuous and differentiable. By the way, the other two only require continuity, basically because it doesn't matter what their slopes are doing. MVT requires differentiability and continuity. So h of t is differentiable. That's given to us. So how do I know it's continuous? Right. Because if it's differentiable, it has to be continuous. Differentiable, therefore continuous, or therefore also continuous. So MVT applies. Again, your precise wording doesn't really matter, but you would definitely have to say differentiable and continuous. So calc slope equals algebra slope. Well, calc slope, that's what they're talking about. H prime of t. And I don't think many people mess this up, but sometimes students aren't sure, which values should I use to find the slope? Well, almost always it's going to tell you which to use. So let's use 2 and 10 and see if that works. So 15, whoops, I said 2 and then highlighted 3. 2 to 10. So that would be 15 minus 1.5. Skeptical that this is going to work now. Over 10 minus 2. That's going to be 13.5 over 8. That's not 2. It doesn't mean we've done anything wrong. We just guaranteed that there's a slope of whatever 13.5 over 8 is. But what we want is to pick two values that give us 2. So 2 and 10 didn't work. Can you spot two values whose slope would be 2? This is where you got to be kind of quick with the math. Caden, you're nodding. James? Yeah, these, that would give me a slope of 2, because the change in y is 4, the change in x is 2. So we tried 2 to 10, that didn't work. So let's try 3 and 5. 6 minus 2 over 5 minus 3 equals 4 over 2, which is 2, on 3 to 5. So we did like one better than they asked for. They said there must be some time between 2 and 10, and we're like, all right, let's try 2 and 10, but 2 and 10 didn't work. So that forced us into finding a window where our slope was 2. So we narrowed it down. We're saying it's not just from 2 to 10. We're saying between 3 and 5, the average slope is 2. Therefore, the precise slope, the calculus slope, is 2. Somewhere between 3 and 5. Yeah, it's kind of mean when they force you to find one, because that forces you to do a bunch of little math problems until you find a slope that works. I feel like most of the time, start by trying the values they give you. Hopefully that'll work. Part C, trapezoidal sum. With 4 subintervals to approximate the height of the tree. Oh, the average height of the tree. Ooh, be careful here. So average height, average value is 1 over b minus a, integral from a to b of h of t. There's a lot of people in this problem that they know to do the integral because it tells you to do the trapezoidal sum. So like, okay, let's do the trapezoid sum. But they'll forget that 1 over b because we're looking for average height. So from 2 to 10, use the endpoints. 2 to 10, h of t is going to be approximated by, and again, we don't have an equation, so I can't take an antiderivative. I don't have a graph. If I had a graph, if it was a nice graph anyway, what's another strategy for an integral? Area. I don't have that. The only thing I can do is approximate it with, in this case, a trapezoidal sum. So let's see, trapezoids. This is just like me reminding myself what the area of a trapezoid is. Base times the average height. I mean, you wouldn't need to write that down, but if your brain blanks on trapezoids, we'll draw a picture and then hopefully you're like, oh yeah, I know how to do it. I know how to do a trapezoid. So 1 over 8 out front, and then I'm going to do the 4 trapezoids. Question, McKenna?
No.
Let's see. So that first trapezoid is 1 wide. A few people got these backwards, the width versus the height. So 1 wide, and the average height, 1.5 plus 2 over 2. And then 2 wide, and the average height. Most of you just wrote it all out, which is how you ought to do it. A few of you on some of these, like, you know, the average of 2 and 6 is 4, so you just put 4 there. That's fine too. Let's see, the width from 5 to 7 is 2. The average height, 6 plus 11 over 2. Then that last width is 3, with an average height of 11 plus 15 over 2. And then most of you on the test left it like that, as you should. Especially on a no calculator question. You don't want to get into the weeds of, I mean, you could, and you'd probably be fine, but why risk it, and why take the time to do it? Like, there's your answer. Use a trapezoidal sum, 4 subintervals, to approximate the average height from 2 to 10. Okay, I think I got that. And then lastly, part D. Usually the tricky part. Uh-oh, there's a lot of words here. height of the tree in meters can also be modeled by this function. So forget the table, now we've got an equation that we could do some of that same stuff with, where x is the diameter of the base of the tree. Oh, so this isn't like as a function of time, it's a function of the diameter. How tall is it based on its diameter? When the tree is 50 meters tall, the diameter of the base of the tree, we'll start writing stuff down. So when G is 50, the diameter of the base of the tree is increasing at a rate, so dx dt, 0.03 meters per year. All related rates. There was a question on the free response question that had dx dt and dy dt. According to this model, what is the rate of change of the height of the tree? Find dg dt when g equals 60. Okay, so g is 100x over 1 plus x. And I need to take a derivative, but I need to take a derivative with respect to time. So dg dt equals, how am I going to take a derivative of this thing? What's the name of that rule going to be? That would be the quotient rule. So f and g, gf prime minus fg prime. Okay, here's the tricky part of this. What's the derivative of 100x when we're taking a derivative with respect to time? So derivative of 100x is 100 times dx dt. It's a chain rule kind of thing. So times dx dt. And g prime would be 1 times dx dt. Okay, so now I need gf prime minus fg prime. So, 1 plus x times 100 dx dt, gf prime, minus the other way around, 100x dx dt over g squared. Okay, do I have everything I need? And the tree is 50 meters tall, not 60 meters tall. So that's G is 50. I don't have X. I need X, though. How am I going to find X? Yeah, they're forcing me to do some more algebra here. So I've got to find what x is, and then I can plug that into all this mess. So a little side detour into algebra. That was kind of on the free response question as well. It asked you to find dy dx when x was 6, I think. But you didn't know y, so you had to go back and plug it in and find y, and then find slope after that. Let's see, so 50 equals 50x. Oh, they were at least kind to us here. X is 1. So dg dt equals 1 plus 1 times 100 times 0.03 minus 100, I'm just plugging things in, times 1 times 0.03, all over 1 plus 1 squared. That's a lot, so my guess is it probably doesn't ask me for like units or what does this mean. Nope, just that's all it asks. So there's my answer. ugly as it is. Ooh, that took us a while. That took 20 minutes. They're supposed to take 15. Recap. Why did that thing take longer? Oh, we took a little side detour about EVT, IVT, MVT. Maybe that took up some of the time. All right, so question 1's done. I didn't print out or look back at all of the point values on these, but there are lots of places to get partial credit, and a bunch of you did that on the test. Like, you would write down something that you thought really wasn't worth a whole lot, but it turns out it was worth a point. In fact, there was one problem where you had to find that weird volume problem where it didn't give you the formula for G. You remember what I'm talking about? It gave you one formula but not the other formula, so you're like, how do I do this? Well, it turned out if you even just wrote this, that was worth a point. Like, the format of the answer was worth a point. And then if you plugged in F and G, that was worth another point. Now, you're right. It's like, well, how do you get G? That was more complicated. We'll work on that later. But so you could have got 2 of the 4 points without doing a whole lot. And again, I graded these last night. And I think, if I remember right, Addie, I think you got 2 of those 4 points for writing the formula. Like, you didn't do anything else because you were stuck or didn't know. But you wrote this, and then I think you plugged in F.
Wait, was that D?
And G. I think it was part C, if I remember right. And 0 to 3, maybe. I don't remember what the numbers were. But like, you literally only wrote that, and because of how the points were distributed, that was worth 2. All right, let's look at number 2. Another table. Do number 2, or do I want to do? Let's do one that has. Okay, so here's why I'm not doing number 2, and you'll do number 2. 1 and 2 both have values that are not rates, so they're probably going to ask you about rates. Let's do number 3, because number 3 gives you a rate. So that means I'll need to integrate to get back to values. So let's try number 3. Yeah, even before I read the question, it's giving me a rate. So already I'm thinking, I integrate a rate to get the change in the amount. And I can't really integrate an equation because I don't have an equation, so probably another Riemann sum here. Okay, let's read the question now. Water is pumped into a tank at a rate modeled by W. So this is the into rate. So I've got an equation for the into. I wonder if R, now let's just keep reading. From 0 to 8, where T is measured in hours. Water is removed from the tank, modeled by R. So I've got an equation for the into, but a table for the removal rate. Selected values of R shown in the table above. At time 0, there are 50,000 liters of water in the tank. Part A. Estimate R prime of 2. Show the work that leads to your answer. Indicate units of measure. Okay, we just did this on that last one. R prime of 2. I don't have an equation to take a derivative of, but I've got a table that I could use, and we'll estimate it with an algebra rate of change. And at 2, I probably want to use 1 and 3. That would seem to make the most sense. So 950 minus 1190 over 3 minus 1. And I did the math on the last one, but I don't have to do that on this one. Wait, little note to self here. We started this one at like 23 minutes. We'll see how long it takes. I can safe stop that. So I'm good. Show the work that leads to your answer. That's fine. That is the work that leads to my answer. Indicate units of measure. Well, 950 minus 1190 is liters per hour. And then 3 minus 1, that's hours. And so I can leave that. Like that's sort of a safe stop for units. It's liters per hour, sort of a liter acceleration almost. But that's fine, I can leave it as is. So I safe stop the number and I've safe stopped the units. I'm glad it didn't ask me to explain that, because that would be it would be the rate that the rate changes. That would be weird. That's probably why they didn't ask for the explanation. Part B. Oh, here we go. Use a left Riemann sum with 4 subintervals. Right, that makes sense because I would have 4 subintervals. Indicated by the table to estimate the total amount of water removed from the tank. So if we integrate R, that will tell us the amount that's removed. Integrate R, that'll tell us the amount that's removed. Is this an overestimate or an underestimate? Ooh, don't know about that yet. I'm peeking back at the R is differentiable and decreasing. Okay, I think that decreasing will help me know if it's over or under. Okay, so we're going to approximate it with a left Riemann sum. Left tells you which height to use. You're always going to use the width, right? Whether it's left Riemann, right Riemann, midpoint, trapezoid, you're always using the width. So width is 1, left height is 1340, width is 2, left height is 1190, width is 3, but the left height is 950. And then the width is 2 with a left height of 740. So there's my approximation. Again, safe stop. I don't want to do that. I don't want to multiply all that out. But I need to know if it's an over or under estimate. I would draw a picture. And maybe an exact picture. Like if you want to be precise, you could plot those points. But I know it's decreasing, so I'm just going to get a general idea in my head of what that looks like. And if I'm doing left intervals of a decreasing function, then is that an overestimate or an underestimate? My rectangles are an overestimate. Now, the picture isn't justification. Like the picture might help you know what the answer is, but you can't just say, there's my justification, that picture right there. Like that's never enough. It's good, it's helpful, but it's not enough. A few of you did that on the test. You justified with a picture. And usually the picture was great, but you have to put it into words. It's like what's going on in the picture. So a left Riemann sum of a decreasing function is an overestimate. Sure, the main words they're looking for there is the left sum decreasing function is an overestimate. And you don't even need the picture, but the picture sure makes it easy to figure out if it's over or under. All right, part C. Use your answer from part B. That means I don't want to do that though. I don't want to calculate that. So I'm going to call that something. I'm just going to call it A. I don't want to call it R because that variable's already taken. So A is the amount removed. All right, I don't really want to calculate that, but I need it, so now I've got it. A is the amount removed. Part C. Use your answer from part B. That was what we called A. To find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, so there's some going in, there's some coming out, and we started with 50,000. So we started with 50,000, we added some, and we removed some. A little bit of a word equation here. So added was the W. So how do I figure out how much was added? Yeah, I'll integrate W from 0 to 8 minus, we already calculated how much removed, we called it A, so rather than like either calculate that or rewrite all of that, let's just call it A, and now we're good. So there's the answer. It didn't say whether this was a calculator one, but it didn't say to write an integral without evaluating it, so my guess is we're supposed to use a calculator to find that. To the nearest liter. So it actually wants an answer here, which means I got to put all this stuff in there. Math 9, 0 to 8, 2,000. E to the negative x squared over 20 dx. Be careful, don't round to the end in case it matters. 7836.195. And now I got to go back and figure out what A is because it wants an answer to the nearest liter. But that's not terrible because they spotted me a calculator. 1340, 2 times 1190, 3 times 950, 2 times 740 is 8050. And be careful, that's not a safe stop for this problem. Did I do something wrong?
No.
Yeah. That's not a safe stop for this problem? Why is this not a safe stop for this problem? Yeah, it's said to the nearest liter, so I can't just leave an answer and say, good enough. It wants an answer to the nearest liter. So 50,000 plus that number minus 8050, 49,786 liters. Integral of rate gives you the change in the amount. We've seen that a bunch. And they like to give you something for the added and something for the subtracted. And they really like to do it where one of them's an equation and one of them's a picture or one of them's a table. Force you to do integrals a couple different ways. All right, part D. Here's where we go make our 5 here. For 0 to 8, is there a time when the rate at which the water is pumped into the tank, is there a time in which the water pumped into the tank, that's W, is the same as the rate at which the water is removed from the tank? Explain why or why not. Actually, this is nearly the same question as that the bike question on the test. Brandon and Charlie, and I don't even remember their names. One was B and one was C. And they even gave you a table for one and an equation for the other. So W of T equals R of T. Is there a time when they're equal? It's the same question, right? That question was there a time when they're the same? Let's see. W of 0. Let's find the endpoints. Maybe that'll be good enough. E to the 0 is 1, so W of 0 is 2,000. W of 8 is 2,000 e to the negative 64 over 20. Oh, but we've got a calculator, so I can figure out what that is. Can't do that in your head? Give me an approximation of that. 81.524. Is that what was in your head? Perfect. 81.524. R of 0, some of you, I'm using a method that some of you used on the test. R of 0 is 1340. Just getting from the table here. R of 8 is 700. So how can I phrase this? This is one where a bunch of you drew pictures to sort of help you see what was going on. So like W went from 2000 to 81. Whoops. 81. 2000. R went from 1340 to 700 at the end. And so the answer is yes, they had to cross somewhere as long as they're continuous. So W and R are continuous. I bet that was given to us. R is differentiable. And so now I have to come up with some way to say what the picture shows. It's related to IVT, so I need to think about how to phrase this. And you don't ever have to use those exact words. So some of you got credit for using IVT, even though you didn't ever say the words IVT. So it is an IVT problem. Let's see. Some of you like spelled it out. You're like, initially W is bigger than R, and at the end R is bigger than W. Therefore, they had to cross somewhere, and that's okay. That's explaining IVT. What the key said was something like, at time equals 0, W is greater than R. At t equals 8, R is greater than W. If they're continuous, they had to cross somewhere. We don't know where, but somewhere on 0 to 8. In fact, the key on that problem, the bike problem, said something like considers R minus W or W minus R, or like compares them. And so I may have been generous. I gave a few people a point on that because like I could tell what they were doing even if they didn't spell it all out. IVT doesn't work unless you have to say it's continuous. So if you didn't say continuous, you only got one of those points. So that was a place where I was like, oh, a bunch of people are going to get one more point than normal after we go over this, because IVT, you got to say continuous. Okay, so that's a weird one, but that's exactly like that bike problem. Let's see, we started this at 23. Now we're at 38. So that one took exactly 15 minutes. And that had, lots of explanations and pictures going on. Okay, well, we're almost out of time, but that's okay. That leaves you to do number 2 and number 4. Number 2 and number 4. All right. Thanks for working with me. Like, we're getting there. Like, we are reviewing, and you're going to bump up from whatever you made on that AP test, you're going to bump up a point by the time we get to May